Okay. Okay.
Okay, so. Hi there. Well, yeah, it does everything except load my presentations.
That's problematic.
Yeah. So I've got them on this, I'll go ahead and run them from here, but this doesn't get me. If I go to the agenda and I say, fine, I can, this is my agenda, this is my charter, this is a map.
Can you drive for a sec? There. Yeah.
Okay, except that PowerPoint. I'm going to run that through here.
Well, it's okay. We can actually do PowerPoint. Right.
Yay.
So.
Okay. So I actually want to run it as PowerPoint.
Oh, you need to run it as PowerPoint.
I need to run it as PowerPoint.
Okay.
So.
That's why nobody's dinged me about submitting my slides as PDFs.
Yeah.
PowerPoint is just fine.
Yeah. Well, if you have to do it as PowerPoint, it's probably better to do it from your own.
Yeah, I'll do that. Okay, thank you much.
Okay, you're welcome. Do you want to use the clicker on your own computer? Or you
That
have your
doesn't
own?
work on my computer either. I have my own.
Okay.
No. I'm sorry, I just have to be difficult.
No, you're not difficult. There are some deficiencies.
Yeah, okay,
All right, well, have fun.
okay, thank you.
Okay, enjoy it. We definitely gotta move the HDMI over to you, though.
Oh, well, not yet.
Okay.
I'll get there,
All right.
but I'll show my agenda first.
Okay. And this will be. Yeah.
Yes.
Screen? Okay. Okay.
Okay,
Well, you guys have fun.
thank you. Okay, so it's 9:03. Does that work? No.
Sounds good to me.
Okay, so it's 9:03. You're looking at the agenda that we have posted today. Ron and I have a couple of questions we need to deal with, and then we'll move directly into the thing. But is there any bashing that people want to do to the agenda? Do I need to change the agenda in any way? Seeing none. Okay, so two questions. One, between IETFs 101 and 102, and then IETF 102 and 103, we put out a question every week or roughly every week saying, let's take a look at a draft and comment on it. Our perception is that work has worked reasonably well, that people have looked at the drafts, they've found the load acceptable, and we've gotten comments on a variety of drafts. And in at least one case, we discovered that the working group wanted to adopt a draft, and we hadn't figured that out. And so that became clear, and we adopted a draft. But I'd like your opinion, because I've just gotten kind of a few comments here and there. As a working group, what do you think about that process? Is that working for you? Is that helpful? Is that something you want to do?
Raise your hand if yes.
Okay, I see a lot of yes. Raise your hand if no. Okay, we'll continue doing it. Okay, second thing, I'm going to turn over to you.
PD host draft. Okay, we have a draft PD hosts that has been kind of flailing, looking for working group adoption or not. I have two questions about that draft. First, raise your hand if you are familiar with Fred Templin's PD host draft. Okay. Of the people who are familiar with it, how many think that it should be a working group item? One. How many think it should not be a working group item? 1, 2, 3, 4, 5. Okay. Would you like to make a consensus call, Warren?
I don't see consensus for adopting it.
Okay.
But I do not see consensus.
Oh, we're not walking to the mic. Are you walking to the mic? No, okay. Okay, so I think we have an answer.
Is there anyone who wants to speak strongly against that?
Yes, there was one person. Do you want to speak in defense of it? No? Okay, so we can move into the agenda.
Okay, cool. And with that, I'm going to switch to the other laptop. So, Xingli. There we go.
So good morning. This is about the China Education and Research Network IPv6 only practice, including backbone servers, clients, and IPv4 as a service. Okay, then that's the outline of my presentation. So actually, we have two backbones, China Education and Research Network. One is called CERNET. It started in 1994, and it's IPv4. Currently, we have 38 POPs and about more than 2,000 universities. And another project started in the year 2004, which is called CERNET 2. Actually, the interesting thing is here. It is an IPv6 only starting from 2004. And currently there are 25 POPs and about 1,000 universities connected. So you can see they are separate backbones. And when we start CERNET 2 design, then actually there are several questions we asked ourselves. The first, should we start using dual stack or IPv6 only? And the decision is IPv6 only in 2004. I will give you reasons later. And also we have some kind of promotion strategy. Basically it's high performance in the free. Another thing is the security, because IPv4 there are nets. And we sought the IPv6 because there is no net 6.6. Then probably we can restore the end-to-end security, and that's the thing we call source address validation architecture. And we work in IETF that turned into the Savvy working groups. That's for the first hops. And then we talked about, we sought the transition, and actually because that's the IPv6 only backbone, so we thought we can do things opposite. So IPv4 over IPv6 at the time. Also, we thought probably V4 and V6 should talk directly through some kind of translator. Then that actually we work in IETF Behave software and this group, V6OPS. So the promotion strategy and the plan is for performance. For CERNET, it's IPv4, and it is because there are 2,000 universities connected and it's congested. However, CERNET 2, it's IPv6 only, and it's light loaded, at least from the beginning. So high performance for IPv6. Another thing is, actually, even we are academic network, but we do not have operation fees from the government. The university professors and the students pay the connection fee, so that's some kind of sharing model. So CERNET IPv4 is not free, and the SUNET2, IPv6 only, it is free. So actually, what's the promotion slogan we told to our members is, if you want to use a free and high performance network, then please use IPv6. So that's the way we promote from the beginning. And tell you the truth, it's quite successful because about half of, the IPv6 to IPv4 traffic ratio is 50%. So however, in reality, we thought, can we turn off SUNET IPv4 for a single day and see if the user is still satisfied with our network? And the answer is no. So the users need to communicate with the IPv4 internet. Even the network is somehow congested and not free. So that's why we move in this direction. And so there are things, that's a summary. For security, that's SAVA and SAVI. Those are the RFCs related in the SAVI working group, mostly in SAVI working group. And for SUNET, some campus networks we actually deploy SAVI technology, so make the source trace possible and more secure. So that's the thing. And for transition, actually, that's a brief history. Starting from 1994, that's IPv4 SUNET. And in the year 1998, actually, we start to connect to 6-bone, and that's IPv6 over IPv4. The reason we realized we need to work on IPv6 is in mainland China, there are 320 million students. That's definitely we cannot get enough IPv4 address from APNIC. And in the year 2000, we tried USTAC, which is called Natural Science Foundation Network. And later, as I mentioned earlier, in 2004, we start IPv6 only SUNET2. Then we thought we can do innovation. So as IPv4 over IPv6, because that's an IPv6 only backbone. That's turned into the IETF software working group. And then later we work in the Behave working group, that's translation, stateless translation. And we call IVI because in Roman representation, IV means 4, VI means 6, so IV actually means 4 and 6 can talk. And then later we realized there is some application embed IPv4 literals and some applications IPv4 only. So we thought probably we can do double translations. So that's double IV, we call that. And because it's something 464 issues, and by that time actually Behave working group closed, declared a victory. So we move back to the software. And then later we realized actually double translation and the encapsulation is something quite similar. So that's into the outcome of the RFCs MAP-T and MAP-E. So that's the story for our experience. So those are the related RFCs. And for single translation and the IPv4 as a service, actually the color marked blue are the RFCs actually we deployed in the SUNET2 backbone. So that's basically the thing. So currently that's the situation. We have 2 backbones, SUNET IPv4 and the SUNET2 IPv6. Actually, we have multiple stateless translators deployed between SUNET IPv4 and IPv6. The reason we can do multiple because that's one-to-one translation, that's stateless. So no matter what's the traffic in one direction can go back to the other address family in another translator because it's stateless, just like the BGP load balancing things. And then actually we have IPv6 only servers distributed in different universities who connected to SUNET2. Also, there are IPv6 only clients or IPv4 as a service clients distributed in different universities via second translators. So the first translator or the core translator are all the same, stateless one-to-one mapping between V4 and V6. And depending on the hosts and the systems, either as a single translation or double translation, or even some kind of encapsulation, or not, in this case, no encapsulation, just the translation. So that's the thing. And okay, again, talk a little bit of backbone, because CERNET 2 is a IPv6 only backbone. So CERNET 2 has its own address block /32. And some campus networks have their own provider independent IPv6 address blocks, so BGP connected to those universities. And if inside the /32 CERNET, then that's static route. And the link speed is 2.5G, 10G, and 100G. IGP is OSPF version 3, and the BGP, that's IBGP, eBGP, whatever. And another thing I like to mention is multicast. We run SSM in the CERNET 2 backbone. And actually, the restriction is the user cannot use their own /48 as the SSM source, but instead we assign a special block as the source address of SSM. That's a better security control. Another thing is the unicast, actually the routing except the link change or those kinds of is static. However, multicast, it's depending on the joint situation, it's install that route or not install, and that make the security and the scalability or whatever performance is some kind of disaster. So actually, because SSM, so it's predefined, so we have static join for the groups. So the whole CERNET 2 backbone IPv6 SS is static, not dynamic for multicast. So that's the thing. And further, actually, there are the tools for CERNET 2 IPv6 only backbone, the routing. And we are thinking we should try SRv6, but not yet. We're looking for that. And the translation, as I mentioned, the stateless translation, and the encapsulation, and the SSM. So those kind of things. And some kind of source address validation beyond the first hop. So that's SAVA. And because there are multiple prefixes, so we try to define some kind of controller to control the prefix. So make some kind of SDN, right? And for the first hop, for the end users, that's the CP, RA, and SAVI. So that's basically the structure in the backbone. And the IPv6 only servers. So actually, we deploy IPv6 only servers with the IPv6 address is based on RFC 6052. So the IPv4 address directly embedded into IPv6 address. So if the user connected to this server using IPv6, that's connected directly. If connected through IPv4, actually that's the user sees the IPv4 address, but actually it's translated to that IPv6. And because it's stateless, so actually multiple translators can be used to do load balancing or those kinds of things. And so currently we have 4 10G translators. It's all congested, but the performance is still relatively okay. Okay, and the IPv6 only clients, that's the interesting thing. Okay, for the partial function, okay, that means if your application is IPv6 and no IPv4 laterals embedded into that, then actually support a lot of operating systems. And that's the CPV, okay. Okay, I repeat again. for the clients, there are two kinds of clients. One client can support the DHCP-V6 state 4, except Android. Most of the operating systems can do that. Another is cannot support IP DHCP-V6. That's mainly Android and Windows XP, for example. So those two things, and we have two SSIDs for wireless. One is for DHCP-V6 state 4, another is DHCP just the RAs with the RDNSS. So that's the IPv6 only. That's the one direct dimension to look at the problem. Another direction is, okay, if, for example, the iOS and Android with 464 X late, then actually even their IPv4 literals embedded or IP, then still you can use that. So that's we call the full function support of the IPv6. And the partial function support is, okay, if the web page with DNS, no problem, because DNS 6.4, we can access those kind of information. However, if IPv4 literals embedded URLs, then you cannot, you fail. So that's basically the thing. And
Qingwei, before you move on,
okay.
I'm guessing that Jordy has this question in his mind. He's asked a number of times, when we talk about IPv6 only, what do we mean? Do you mean here that you're only giving the client an IPv6 address? It doesn't, there is no IPv4 there at all? Is that the definition of V6 only?
Yes.
So, Jordy, do you have more to question there?
My point is that it's not that simple as that. When you say a network is IPv6 only, if there is some IPv4 function, even if it's at the end of the upstreams, let's say, you are translating, so that network is not IPv6 only. My belief is that we need to start speaking about, when we say IPv6 only, which specific part of the network we are talking about. It's the LANs, it's the access, it's the core, it's the upstreams. I think that's the only way to really have a clear picture for everyone. That's the thing.
Okay, thanks. I agree. Okay, actually here I mentioned IPv6 only is IPv6 only subnet. Does that answer your question, right? So IPv6 only is subnet. Okay. Actually, a little bit more complicated. That's to the subnet side. And to the application side, actually there are two cases. For example, iOS, that's single translation. So to the application socket is still IPv6 only. However, for Android deployed 464 X late, actually to the socket function, that's still stack. However, the subnet still IPv6, right? That's clear, right? Thank you. And another thing is for latency, yes.
One question, Bob Hinden. So over in 6-man, we're working on this IPv6 only flag thing, so RAs the administrator can use that to tell all the hosts to only use V6. Is this something that's useful to you? Have you looked at this? So in 6-man, there's a draft about having the administrator inform all the hosts to only use V6, to not turn off V4. Is this something that would be useful to you?
Yes.
Yes, okay. Well, please come to 6-man and say that.
Okay, thank you. Okay, and another thing is like, okay, 464 X late is deployed in the operating systems. If for the latency applications or old OS, which is IPv4 only, then actually we deploy translator in the second translator. So the subnet is still stacked. However, the upper stream is IPv6 only. So that's another thing. And frankly speaking, actually at our campus networks, we have two SSIDs. One is IPv6 only subnet. Another is dual stack subnet. However, the upper stream are both IPv6 only. Okay, another thing, actually, so actually this is also IPv4 as a service. So the upper stream is IPv6 only, but the subnet is dual stack. Another thing actually we tried is for high performance computing, IPv4 as a service. And actually, you may know there are some top supercomputers located in Wuxi City, like Jiangsu province in China, middle of China. However, some university, for example, my university, the Bio Research Center use that computational facility, and the data is about like 1 T per day or those kind of things. So actually, we use double translation to provide this kind of service. The reason for that is actually in this case, the IPv4 address is private address, not the public address. So that means 404 to build a VPN. So that's the situation. And the consideration for this is, and the network can be fine-tuned using IPv6 prefix, so that those IPv4 V6 prefix can be put into a higher priority through traffic engineering. So more flexible and controllable than IPv4 BGP, and more cost-effective than MPLS. And the network operation management is very simple. End-to-end address transparency, no encapsulation, decapsulation is required. For example, if the network operator try to take the traffic and do things, if it's encapsulation or tunneling, then the first IP address you see is the terminal address, not end user address. However, for double translation, the IPv6 address embed v4. So you see different end user has different addresses. And no need to upgrade application at this stage. So the user still use IPv4 as the application. And one thing quite interesting for us is the different charging model can be applied via different IPv6 prefix. So because I mentioned earlier, your professors pay the fees for using the internet. However, for this one, actually they can have unlimited usage, and that also make the campus network administrator life is much easier. So there are some interesting discussion things. That's our observation, the feeling. For IPv4 as a service, either use encapsulation or double translation. And we believe we prefer double translation because the double translation can reduce to single translation and eventually as IPv6 only. However, encapsulation, you need to keep 2 points. And also the traffic engineering, as I mentioned, I have a figure later to show that. And the second, the stateless or stateful, because stateless can restore the end-to-end address transparency, and it's much more easier for scalability scale. So if possible, try stateless. If no choice, then stateful is fine for us. And the RFC 6052 address are other mapping algorithms. And we believe that the IDC mapping or those kind of things, we believe we should make the wire, the people take a look at the wire, know what's the IPv4 literals embedded. So make it as transparent as possible. And the same IPv6 prefix for the source and the destination are different IPv6 address. In RFC 6052, actually, it says you should use the same prefix. And however, that can result, okay, actually, same prefix can result in the optimal routing. However, if you have 2 administrative domains, then probably the only choice use different prefix. And finally, for the clients, DHCP-v6 or Slack. Actually, we like DHCP-v6. Unfortunately, Android cannot support, so we have no choice. We need to support Slack. So that's some reasons, right? because this is quite interesting from ICANN. The IPv6 address per capita and the GPD. And you can see the high GDP or developed countries, the IPv6 is quite good. However, for the less developed or developing countries, there's no IPv6. So probably the IPv4 will exist for decades or many decades. And if we want eventually get an IPv6 only, then we need to deploy translator in some place of the internet to keep a single internet. And this is actually, I said, in the wire, the operator can take a look at the IPv6 address without decapulation to do ACR or traffic control or rate limiting. However, if there's turn-in technology, you can not do that directly using the existing tools. You have to do decapulation and limit the traffic. Otherwise, you limit all the traffic in that provided by that terminal point. Also, the end-to-end address transparency I mentioned. So on the wire, if we know what's the IPv4 address embedded, we can do a better control. And that's the optimal routing. So if it's the same prefix, then no matter the IPv4 is used in IPv6 or translated in IPv6 or in the original, no problem. The longest the prefix match can automatically redirect your traffic into the right place. However, if different prefix, then you need to do like whatever hairpin or those kind of things. And the IPv6 only support, as I mentioned, the 4 function. So for iOS 9.2 and above, and macOS 10.13 above, and 464 X-Late Android. Actually, that's quite good. Like originally, 464 X-Late can only support the LTE interface, but currently above 6.0, the WLAN support, so it's very good. And I heard the Windows 10 can support, however, the home edition we tried have not, we don't know. But eventually that will support. That's a very good news. However, one thing is if you want Slack, you have to be very careful because Windows 7 cannot support RDSS. That's the problem. If, I don't know, Microsoft can have upgrades or patch, that will be great. So finally, what's our feeling is IPv6 only with single translation if you can. IPv4 as a service with double translation or encapsulation if you should, and the dual stack if you must. And the way to IPv6 only is 4 as a service, IPv6 only with single translation, and eventually IPv6 only. So thank you very much. Any questions?
Hi,
Thank you.
Bea? My name is Natalie. I noticed you are using an interesting prefix for your network. It's 2001 DA8, I think. It's very close to the documentation prefix, which is 2001 DB8.
Actually, that's the real Ethernet 2 prefix.
Yeah.
That also surprised us.
Exactly. Did you ever had any issues with that?
It seems okay.
Okay.
Fine. Maybe some mistake, right? They thought Ethernet 2 actually we are using document address.
Okay.
Not yet. Maybe.
Lorenzo Coliti, I wanted to ask you what mechanism you used to discover the NAT64 prefix in the host. You mentioned RFC 7050, and also you mentioned this table in 6052, which has got different prefix lengths and suffixes. But I know that the 7050 implementation in Android only supports 96s.
Yeah,
so,
right. Yes, exactly. So in that case, we use /96.
So you use that /96.
Yeah,
Do you see any reason not to use /96?
Okay, actually, that's a very good question. We actually prefer some kind of stateless translation. So if we want to use a address representation defined in like map T, then actually we can not use the /36. In that case, actually the compromise is the source address as the map T format, however, destination address is /96.
So, okay, so right now you can only do 96.
Yeah.
But you would like to do something different.
Sure, definitely if Android can provide that function, that will be great.
Well, actually, the reason I ask is that in 6-man, we're talking about deprecating everything else. So,
For our practice, then we use different prefix. Then we need some other things, not optimal routing. That's the trade-off.
I see.
I cannot see why not use other prefix lengths rather than 96 too, because that's it. 70, 50, then actually you can discover everything.
Yeah. There's a draft in 6-man later this week we're presenting. The reason for not supporting it is that it would make the option 50% bigger in the array. There's no space for prefix length if you want it to fit in 16 bytes. So yeah, maybe you might want to comment on that, because we're not aware of any implementation that supports it. Actually, I think the iOS implementation does support it. Did you verify that iOS supports non/96?
Yeah.
It does.
No.
It does
iOS
not.
Does not. Right.
I
The
thought
same.
David told me he wrote it, but clearly
We tried.
didn't work.
It doesn't work.
Okay. All right. Thank you.
Thank you.
Well, now, Xingli, let me comment on that. When you started building IVI, which was 2008 or something like that, your argument for the way you structured the address was that you wanted to straddle the IPv4 address across bit 64 so that you could use IPv6 routing to take traffic to different places and have multiple hosts in a given place. But basically, it became a routing game. Are you still doing that in IVI?
Yeah. Yes.
So you are not using a 96. You are using a
Yes.
40 or
48 or 40. Yeah.
Yeah.
Basically, the example I gave is still using 40, not changed.
Okay.
Yeah. The 40 says the nice is /24 IPv4 subnet equivalent to a /64 in IPv6. So that's the reason. Yeah, we choose 40.
Yeah. So an additional comment there then, Lorenzo, is that they are using it in a way that they use routing within the SerNet2 network based on parts of the IPv4 address.
Actually, our plan is at some stage, we move all the IPv4 address into IPv6 and turn off IPv4.
Okay.
Thank you.
Okay, so thank you very much. I don't see anybody else at the mic, so I'm assuming we're done. So, okay. Jordy? So hang on a second, I'll get you going. So
Nothing here? No. Okay.
okay.
It's okay. Okay, so the first document I am presenting today is the NAT64 XLAT deployment guidelines. The origin of this document was a discussion that we had in the IETF mailing list about setting up the network with NAT64 only. And then while I was saying there are applications that unfortunately still use literals or all sockets, and that means that will not work for everyone. And then I think it was Christian Utema was suggesting the mistake we did basically was using DNS64, and then I started to work in a document which deployment guidelines for 464XLAT, explaining what are the consequences if we don't use DNS64, and then there was a suggestion from the working group regarding that document to, instead of working in just the 464XLAT, working in a general deployment guidelines for any NAT64 usage. So that's what we have at the document today. Across the different versions of the document, I got sometimes questions like if the document is just talking about NAT64 as a preferred transition mechanism. That's not the thing. What I am not suggesting in the document is this is the way to go. What I am saying is if you already decided to go to NAT64, then this is the way you can deploy it. Not just a discussion, that's another question I got frequently, is not just a discussion about what are the things that DNS64 breaks with DNSSEC. It's one of the important things, but it's not the only one. Okay, so the starting point for the document is there are three main issues which deploying NAT64. One of those is if you are using DNS64, it may break DNSSEC. There is a work from Jen that was talking about 1.7%, I believe. That was about 2 years ago. I guess that will increase if the penetration of the deployment of DNSSEC grows, obviously. The other thing is using just NAT64, there are applications that use literals or APIs that, of course, they are not going to work on that situation. And of course, if you have a network with just NAT64 and you have still all devices or applications that use IPv4 only, they will not work. So that's meaning that in some scenarios, you cannot just survive with NAT64 alone, right? When the DNS64 document was published, there were a few scenarios worked out in that document. And from the perspective of an operator today, I believe there are much more scenarios. And I have done a classification of those scenarios in scenarios that are known to work and those that will work only in special circumstances, which are still valid, but not the generic case. So for the scenarios known to work, there are 4 possible scenarios or sub-scenarios where you have an internal or outsourced NAT64 DNS64 combination. Okay, so that's the first set of scenarios. Then there are 3 additional scenarios where you are using 464XLAT, and either you have an internal or outsourced NAT64 DNS64 combination, and then 2 more possible sub-scenarios where you have 464XLAT, but in this case without using DNS64. And again, you have the NAT64 functionality inside the network or outside the network. Known to work in special circumstances, there is one scenario which is NAT64 without DNS64, another scenario which is DNS64 in the IPv6 host, which is something that more and more operating systems are already including. So it's something that maybe today is not the optimal situation, but it may change in the future. And then service provider with the NAT64 and the DNS64 is in the remote-only network. It seems that this scenario don't make too much sense, because if you have a DNS64 in the remote network, the logic thing is to have actually that remote network which is already IPv6, right? But it may happen. I am trying to do a very quick comparison about these 12 scenarios. At the end, we come to 12 scenarios. And this comparison is based in 4 specific questions. The first one is, Are the hosts in that network validating DNSSEC? The second one is, are the hosts using literal or APIs? The third one is, there are any IPv4 only hosts? And the last one is, any chance the user can change the DNS? I call this foreign DNS because that may break some things that the operator is considering. So, for example, if the operator is providing a DNS64, but the user is changing the DNS, then of course the DNS64 function is not working. So I am rating each of these items depending if they are good or bad in each of the possible scenarios, and then I come to this table, right? I have additional sections, looking at them very quickly. There is a section regarding the DNSSEC considerations and possible approaches, discussing one of the possibilities is not using a DNS64. The other one is the DNS validator aware of DNS64, stub validator, CLAT with DNS proxy and validator, ACL of clients, mapping out IPv4 addresses, and then considerations regarding DNS reverse mapping. Then the usage of 464XLAT, which or without DNS64, explaining what are the differences of one case and the other. Manual configuration of foreign DNS, again, is when the user is able to change the DNS configuration. So that means that the DNS functionality is not under the control of the operator anymore. DNS privacy, because that's another thing that gets broken when you are using DNS64 together with privacy. You are not actually using the DNS64 probably. A split DNS, it's another possible case where the DNS64 may be not working. Comparison between using a well-known prefix or a specific network prefix. Considerations regarding the IPv4 literals and all APIs, IPv4 only host and applications, and considerations regarding the CLAT translation. Then I am doing a summary of all the considerations and explaining also that the document is not just talking about operator networks, because in most of the cases, all the considerations will be the same if you are an enterprise network or you are trying to use NAT64 on that network. So basically, it makes no difference. And then it was, I think it was suggested by Fred to include an example of broadband deployment with 464XLAT and also CLAT implementation. And I'm not really sure that that will be possible, but there was also a suggestion to include some benchmarking. And I think that was it. So questions, because one of the problems I am having is that since probably 2 months or so, I am not getting inputs for the document. So even if this document was adopted as a working group item, is it still useful? Is somebody interested in contributing or saying something? I don't know. Jen?
Jelenkova. I feel a bit guilty because I promised you to read this when I was in Montreal, and I actually finally did. And my feeling is we probably may simplify the document slightly, because I found it that it's my impression that in many cases you might actually just combine a number of scenarios in one scenario. For example, saying you have NAT64, you have DNS64, and it really doesn't matter where DNS64 is located. Because I think currently it's a few different scenarios, which makes the document probably way too long. Because I actually was struggling finishing reading it, because I found too many similar scenarios and you need to sit down. What's the difference between them actually? So it would be my suggestion to think to see if you can slightly simplify it. Also, Martin from NICTZ just recently did more measurements on DNS64 and IPv6, similar to what I did a couple of years ago, and percentage look quite similar. I can send you a link, but it's not in English, unfortunately, so you might need to use Google Translate. So yeah, I think it's useful, but again, as I said, my suggestion would be to review how you make it more readable.
At the beginning, I was having lesser scenarios, and actually I got the input that I should describe more of them. The reality is that I agree, there are some scenarios which are very similar, but this is not actually making the document longer, because if you look at the length of that part, it's because the pictures. So it's not like you need to read a lot of more things, it's because each picture takes half a page, okay? So I don't think that's increasing the complexity of the document, but I think it's providing clarity. If you see a picture, it's very easy. You don't need to read the text because the text is basically not saying anything different. But you have in one case, for example, 4 scenarios, and looking at the picture, you get the idea about all of them. And then the text says, all these 4 are the same, okay?
Okay, so probably, yeah, because I got an impression that I'm reading a lot of similar text saying it's exactly the same scenario above, and then another couple of section of text. So again, it may be just me being lazy.
I can take a look again and try to squeeze a little bit the text, but for clarity, I think it was that way, and that was the suggestion I got before. So I agree. We have different views, and some people will say it's too long, and some others will say it's too short. Please clarify it. And some people were suggesting even additional scenarios, which I don't think we need them, right?
So Jen, let me ask a question. You were on the hook to do a review of the document. Are you still going to do that?
Yes.
Thank you.
Thank you.
So Warren Kumari, sorry, my comment is only slightly related to this, but I didn't think of it earlier, so I wanted to announce it now. So Stuart Cheshire has a document which adds the IPv4only.arpa name to a registry. And you're talking about DNS64, so I figured I should mention it now. Yeah, so the IPv4only.arpa name was never actually added to the special use domain names registry. And so this is more admin stuff. But anyway, he's got a document that does that. It's kind of related to V6OPS. I've agreed to AD sponsor it because DNSOps said, looks like admin stuff, not interested. So I will CC the list when I actually start that, if people can review it. I'm assuming there'll be no comments. You commented and said.
I think I commented on that, and I believe I have a mention in my document about that. So in fact, in my IANA considerations in this document, I am saying if this is not done, we need to do an errata and so on. So I have explicit text for that. Thank you.
Okay, any other comments? So it sounds like we're really not ready to close up on this document until you get Jen's review and whatever comes out of that. So what I'll do is in our list of documents going forward, then I'll ask for people to comment on the document. So Jen, your review will be very helpful. So.
And this Friday, there are some available rooms. So if people believe it's interesting, we sit down together to speak about this document. I am happy to try to set up some time for that. Maybe an option, right?
Cool. Okay, so now, Jordi, you're also an author on this one.
Yeah. Okay. So what happened here is this document started as 2 different documents. The older one is the Sunset IPv6 document. Unfortunately, there were very, very few comments on that document, and then Sunset is sleeping, so there is nothing to do that. And then Cameron from T-Mobile was sending another document, and I think it was somehow Fred's fault that Fred was suggesting to merge Cameron document with the previous document that I have presented. And my comment was, no, it don't make sense. I mean, those 2 documents don't work together. But then I realized that the ideal thing would be to merge these 2 documents. And I talked to Cameron and he agreed. So we drafted a document which basically is saying, hey, DNS64 is widely deployed. 464X-LAT is widely deployed. We have also support for DNS64 in happy eyeballs. We have also NAT64 widely deployed, especially in cellular networks. There are millions of hosts using those mechanisms. And what happens is that host validating DNSSEC may fail. The same comment I did before. It's true that most of the cellular networks, the smartphones, are not validating. I think they have functions that can be called by applications to validate, or that can happen in the future, but today is not used. But what happens when you are doing tethering and there are hosts behind that may be validating? So it's still a problem. So the other consideration is a big cost of the transition is on the back of the ISPs, okay? Because at the end, the ISPs are the ones that need to deploy these transition features and need to solve the problems if DNSSEC is broken or whatever. And at the end, that means the users are paying somehow for it, because of course the ISPs will carry the cost to the end users. So why not try to find a way for content or application providers to carry at least part of the cost, okay? The thing is, if they have the technical ability to do DNSSEC, they should have as well the technical ability to do IPv6. So that will solve the problem, clearly. If we have IPv6 in every DNSSEC host, we don't have DNS64 breaking anymore that functionality, right? So the thing we are trying is to find a way to push the application or service or content providers to deploy IPv6 if they are deploying DNSSEC. That's the first thing. And then indirectly to assume part of the transition cost as well, and find a way to give them clear signals that this should be provided. They should really make an effort on this. That's the thing. So the goals of the document is, let's make sure that DNSSEC infrastructure is ready with IPv6, so DNS64 is not any longer a problem, even just for 1.7% of the cases. 1.7% of the cases in a help desk of an ISP is still a lot, obviously, so we need to try to sort out that. Make sure there is a plan for the rest of the DNS infrastructure to be as well IPv6 ready, okay? So one side is DNSSEC, but not only. Let's try to figure out how to work that. So what we want to mean with IPv6 ready is that IPv6 is accessible, that there are quasi-resource records, that PMTU is not broken, and so on. So that's easy. So we are trying to define a timeline to make this happen. And the timeline is root and TLDs, and we know that most of them are already done. Roots are done already. TLDs, I think 99% of the CCTLDs are done, but there are still some GTLDs that are not done, despite the ICANN contract mandates for that. So that's interesting. There is a contract that says you should do IPv6, but it's not being enforced. So we are asking them to be ready with IPv6 in 6 months, the same for DNSSEC infrastructure, and then the name servers in 12 months, another resource records in 18 months, and then have IANA or ICANN or both of them doing a validation and forcing somehow suspension to those registrars that are not doing that. Is this an utopia? I don't know, but clearly there is a contract which ICANN that is not being followed. And yes, we are IETF, we are responsible of the numbers, so somehow we are indirectly responsible that this is happening or not, right? And there is clearly some kind of infrastructure or liaison or whatever which ICANN that we should work together. So maybe the document is not the last word on this clearly, and maybe it's not the only way to go for this, but we should do something. And that's, I think that's the last slide. Yeah, that's the thing. So throw tomatoes or whatever, I know, Jen.
So let me be clear on this. You're asking ICANN to essentially take a regulatory position?
Well, if you have something in a contract and you are not enforcing it, why you have it in a contract?
So Jordy, it's
Yeah.
Dan York. I spent some time before when I was in more of an IPv6 advocacy role, and I was very excited when that contract that you're referring to, it's the registry agreement. But the detail is that only applied to the new GTLDs. It did not apply to any of the country code TLDs, et cetera. So I think, and most of all of the new GTLDs are IPv6 because they had to be in order to be launched through the ICANN process. So that was, so regarding that, the contract point, it is affecting all the ones it can affect. So there's all the other domains, the CCTLDs, the other pieces that were not part of that in various ways, although Warren may be able to correct me if he has, no? Okay. All right, looking at him.
And
I'm sure you're right.
Okay.
I know in fact it's not affecting CCTLDs, but luckily CCTLDs, there are only 3 or 4 that are not still doing. So that's the meaning of the problems.
So,
yeah.
Okay, anyway, I don't know that chasing that's going to do too much. My larger question though was, or two, one was, have you brought this at all to the DNSOP working group?
I think I forwarded the copy or somebody copied and I didn't copy it because I saw somebody already posted there.
Okay, well,
but I didn't get any inputs.
I would encourage you to do that. I will admit I haven't been following as much here, but I have been over there, and I think that would be useful to provide that input to. But the other part, when you ask about DNSSEC and saying that, so I agree with the goal, right?
Yeah.
But I think from an implementation point of view, I'm not going to necessarily sign any Quad A records if I don't have them. If my web server is only accessible over v4, then, which is what the DNS64 needs, right, to get to me? So
of course, we are not asking for that. If you don't have transit with IPv6, you should not have Quad A records. That's clear, yeah.
But then how do you put, I mean, in what you're really saying in this is that everybody should get their websites and everything else to work over IPv6, which, yes, I completely agree with that, but I don't know that necessarily we can, I don't know, I don't see it necessarily being something we can necessarily create right there.
And Mark Andrews is in the queue.
Yeah.
At the TLD level, I agree, everything's pretty much right. The problem is the assumption, you're making an assumption here that if you can do DNSSEC, you can also do IPv6. And once you go down a level beneath the TLDs to the actual enterprise, that isn't true. It is not true to a large extent. To do DNSSEC, all you have to do is deploy a name server which supports it and register your keys in the parent zone. That is something we've been able to do for 20 years, nearly now. It doesn't, there's no gating on ISPs delivering your IPv6 over access network and anything else like that. So anything which actually slows down DNSSEC deployment by gating it on IPv6 being deployed is actually a bad idea for DNSSEC. Which is why this draft, as a recommendation, you should do this. Yeah, it's all good motherhood stuff, but in practice, it just won't happen.
So, Mark, so you are suggesting that we just stick to a recommendation and nothing else, and don't work with ICANN IANA to try to fix it?
Well, I don't see there's a real. I don't see there actually is a problem at that level, because the ones which don't have IPv6 aren't contractually required to have IPv6 either. Because there's a set of TLDs which have contracts and they do actually do IPv6. Does that make sense?
Yeah.
Paul Wilson here from APNIC. Very recent discussions with ICANN senior folks showed that they are very interested in this. They're aware that there's a lack of compliance in the support that they're expecting for IPv6 functionality to be provided. But one of the things, for instance, that they're after is that their registrars should simply provide the interface that allows domain holders who have IPv6 to register that into the DNS. So, I think they're looking at that functionality, the question of the functionality offered by their contracted parties. I'm not sure whether there's consensus on whether the contract is correct or not, but they're aware that they've got certain contractual requirements that aren't necessarily being met, and they're maybe not monitoring as well as they could, and they are definitely interested in fixing that. I know that. Thanks.
So it looks like if IANA or ICANN is in this direction, we should work with the liaison to try to define better what we want to do with this document. Yeah.
Jelinkova. So if we think that as you mentioned on the mailing list, that the problem is that DNS operators do not really understand the impact of having DNSSEC enabled without enabling IPv6, then I agree, we need to educate them. So I really like the first draft, which was just saying, if you deploy in DNSSEC, you should think about the impact. You should be aware that some people might have issues accessing your record, so please consider enabling IPv6. That's the right thing to do. However, what your draft is currently saying is that you're suggesting to invent a magic wand, which will get IPv6 deployed globally in 18 months, and I just do not believe it's feasible. So basically what you're suggesting, I could not see how it could be implemented. I just do not see implementation details. And I think you're basically suggesting something which is not feasible. So I do not think we should be enforcing this, because there are countries which do not have V6 at all. People who have sites there, they just could not have V6 in that time frame. It's just totally unrealistic. So I suggest we stick with recommendations and explanations of the impact, and that's it. And as it's been said, DNS ops people need to be aware of this, because at last RIPE meeting, the DNS working group had no idea about this document whatsoever.
Okay, thank you.
Dan York, just one comment that Mark led onto it. I think you are off on the idea that somebody who has DNSSEC expertise is also, if they have that technical expertise, then they could do IPv6, because to Mark's point, activating DNSSEC on a zone is really just a matter of maybe uncommenting a line in one of the config files or doing something like that. And so boom, you do that and it's on. And now you're signing all of your zones depending upon which of the various different authoritative servers you're using. So that's, a very basic thing that you're done, versus trying to get IPv6 transit and IPv6 routing and everything else and firewalls and all that configured. So it's a different technical set. So I would not make that assumption in there. To Paul's point, I think there are people within ICANN and NSRC and other folks who are out there working on IPv6 issues who you would talk to. I don't know that IANA has any role in that type of thing with that, but ICANN would be the folks.
ICANN, yeah. Thank you.
Well, and as far as IANA goes, they're a service function. They do what they're told. So that's not their job. So, okay, what I think I'm drawing out of this, and tell me if I've got this right, you're going to need to change the draft to make that be a recommendation as opposed to a contractual thing. We need input from DNSOP. Either you need to discuss it in DNSOP or get a review from them.
I think it's trying to ask DNSOP to read the document and provide inputs. Yeah. Probably after that, it will be clear that it should be just a recommendation. But I think we should still work with the liaison with ICANN to see if they have some suggestion about the document, about the way to go, and if they can do something. Maybe, I don't know. I am just thinking loud.
Feel free to talk
Yeah.
to the liaison.
Okay.
So are there any other things that I should be pulling out of this? I think those are the 2 points that I'm pulling out of.
Yeah.
Okay, so I have one other question. During the discussion a few months ago on Cameron's document, there were several people who said that they thought his document should go to BCP. So let me ask the working group, if those changes are made in this document, do you want to take it to BCP? Question for the group. If that's a direction you think it should go, would you please hum? The one he's just been talking about.
No hums.
No hum. Okay. Thank you. So okay, so now moving along.
6177.
Yeah. And I'm amazed. You're an author on this one as well.
Yes.
Okay.
Okay. So what we are trying to address here is the perception of many ISPs read the 6177 as something which is not very, very clear. So I decided to speak with the authors of that document and try to see if they want to get involved in this version. And I think we didn't get a response from Thomas Narton, and Jeff said, I am not interested at this stage. And then Leah Roberts said, yes, let's work on that, because she has the same perception. Okay, so the thing here is that we move it from RFC 3177 to 6177, and then we somehow tried to fix the idea that a /48 is good for everyone. However, when you read the policies of different registries, some of them suggest to still use a /48, some others suggest a /56. In any case, it's clear in all of them that it's an ISP decision, and we agree with that. But the people is still doing some strange things, and when we ask them, people, I mean ISPs, when we ask them, they don't have a clear understanding from our point of view of what this document is saying, the actual 6177. So let's make sure that we fix this document, especially to say a site needs to have many subnets, not just one, and a single /64 is never recommended. This is somehow already in the document, but we want to make it more clear, okay? I was working for 2 years and still ongoing in a survey. The last time I looked at the figures, probably it's about 6 months ago, I had almost 1,600 responses from ISPs from all the world. 23% of the ISPs, mainly from more advanced countries in terms of IPv6 deployment, are using a /48 for residential customers. 35% are using a /56, and this is the big problem, there is 33% that are using a single /64 for residential customers, okay? And when we speak with those, they are somehow pointing to RFC 6177. So that's the reason we believe it's broken. You want to say something now, Barbara? Okay. So what we are trying to do in this document is to update the recommendations. Most of them are exactly the same as we had today in 6177. The first one is a single /128 is extremely discouraged. There are not in IPv6 hard-coded boundaries. We use CIDR. One size fits all is not necessary or appropriate, but we still need to ensure that end sites get a sufficiently big number of subnets. A single /64 is not a normal choice. There may be cases, of course, but it's not the normal choice. Neither should be a small number of subnets. And we don't go to define what is small, okay? We don't want to enter into that discussion because that will be endless. N-sites should always be able to obtain a reasonable number of /64s for their actual and planned usage, and over time ranges specific in many years, probably decades. Okay, so we are not talking give the user something for the next 4 years, give them something for the next 20 years. Okay. We are following more or less the existing structure for the 6177 that we have today. Actually, our version is shorter because we deleted some of the sections, but there was one section that speak about Y/48, and what we are saying here is per address cost, considering the charges from the registries is not a problem, so that should not be a showstopper for an ISP to allocate more addresses or more prefixes. Home net control protocol needs subassignment to downstream routers, so maybe /56 may be too short in those cases. Use of ULAs internally matching the ISP prefixes, so the ULA is /48. If you want to match that, which the prefix that you get from the upstreams is not going to work. If multiple links are present, DNS is simple with same prefix size from each link, instead of having different ISPs with different prefix sizes. Business may need more than a single /48, and the actual addressing policies from the registries already allow it. Even in some cases, they still need to go for a justification, but this is something that Google need to fix at the policy level. And I am actually considering submitting policy proposals in all the registries to fix that. Single /64 per host interface is something that was not considered when this draft was done, this document was done, because it didn't exist, so we need to consider it now. And then /48 is not wasteful in many situations, because one of the reasons from moving from 3177 to 6177 was people saying it's wasteful. And then I did those numbers, which is a spreadsheet, to show that it's not wasteful. If we have a /3 that contains that number of /48s, if we are really bad deploying IPv6 and we have a 50% utilization, we have only the half, of course. And then if we suppose we are going to have 32 billion population, and that the average expectation for every human is 100 years, and let's suppose that when everyone dies, we don't recover the /48s that give to them, we can give /48s for the next 100,000 years. If we go for 4 /48s, we have only 12,800 years. And we still have 8 times that space. So if we use all the addressing space, it means that we will have at least for the next 100,000 years /48s. Okay? You want to say something now?
Yeah, Joel Yeagley, that's a curiously naive modeling of human behavior, and addresses are actually not used by humans, they're used by machines. While I don't, it's hard to even criticize the model on which the assumptions in this slide are built on, because it's not well described. But I think it's, I think we can be reasonably certain that assumptions that you have there are completely meaningless. We can use all this address space in 2, 3, 4 decades, maybe, without too much trouble. So 50,000 years is maybe 3, 4, 5 orders of magnitude off.
Okay.
Ron Bonica speaking as an individual contributor. I think this slide may have been more for humor than for actual modeling. Even if he's off by 4 orders of magnitude, We're still okay.
It's still okay. That's the thing. I mean, I am not trying to be accurate because, of course, it's not just humans. It's machines.
You expected us to chuckle when you put that on the slide.
Obviously.
Jeff Houston, not chuckling. Part of the reason why we had a problem with 3177 or whatever it was that in looking at the ratios we were using in deployment, and 50% utilization is a laughable joke. The whole idea of V6 was not to place pressure on operators to achieve address utilization densities which were expensive. The whole idea was to give enough space that it really didn't matter. And the combination of using enough address space that it really doesn't matter and projections of device density meant that assigning a /48 to everything would give us less than a decade if you happen to read the stuff. What I object to about this kind of slide is joke mathematics. It just doesn't cut it. And the case that they're trying to make, that /48s are fine, implicitly behind this, is completely and utterly false in my mind. I reject that as being irresponsible. If what we're trying to do is to utilize the larger address space in V6 not to repeat the phenomenal pressures we placed on this industry to strangle V4 beyond its reasonable lifetime, then what you're doing here is, oddly enough, repeating that same mistake. And the least we can do is learn from this. So no, it's not funny. It's actually misleading and wrong. I'm sorry, it just doesn't cut it for me.
Go ahead.
Christian Wittema. Jordi, I kind of agree with what Jeff said. And one thing you're missing there is that the pressure is not linked to the ratio that you're using. It's actually logarithmic. And we explained that in RFC 4194. And if you do that, you should actually go from there. And if you go into the logarithmic effect, then it's much closer to Jeff's perception than yours.
Okay. Keep going. So, the summary of our document is that exact prefix choice is still an operation issue, and we have a reference to a very recent document from RIPE, which has been co-authored by operators from all the regions, which is RIPE 690. We strongly discourage using a single /48. We strongly suggest considering a /48. Alternatively, reserve a /48 and assign the first /56. That will avoid renumbering the remaining /48, can be assigned if needed later, or use it for other users if it's not needed. Encourage alignment of cellular networks, because that's another thing we have. In cellular networks, we are providing just a /64 and we don't use the HCP and so on. And the thing here is that the reason for that is because it's an alternative to broadband networks, right? Cellular networks are more and more alternative to broadband, and in some cases, there may be users that only have cellular connectivity for their broadband connectivity, and today they got only a single /64. So we want to make sure that that's also fixed. And that's it, basically. So, Barbara? Yeah?
I disagree, Jordi. First of all, I guess on various levels. You mentioned the mobile networks, which are handing out the SAS64 effectively because there is no DHCP IAPD in those networks. And right now, 64 is the best they can do with the mechanisms they're using. Yes, it would be lovely if they handed out more, but I think that putting out some strongly worded RFC that says, you know, we really discourage /64 and sending it to them, and it's like tilting at windmills. You know, there are also operators who have our 6RD deployments. We're providing a /60 and telling us /56 by golly and /48s. Again, you're tilting at windmills, and it's kind of insulting. I mean, we've got IPv6, you know? If you start putting more and more barriers like this in front of IPv6 deployment, then you're actually going to, in my opinion, decrease IPv6 deployments that still need to happen in so much of the world. And I don't think you have made a case for why this extent of address space is really needed.
Lorenzo Coletti, I think this is a tussle, and the reason is that, and the reason I say that is that I disagree with everything you said, Barbara. Well, pretty much everything. I agree that saying it's like, I agree that saying something super strongly worded is not gonna help that much, but I think we have to say something here. I think we have to say, here's what you can't do when there's when you just use a 64. And it's I think we have guidance on this in terms of RIR policies, but we also have to have guidance to ISP saying, look, our protocols are designed for this. And that is a statement that the IETF is qualified to make and has to make, right? I think we wrote a bunch of stuff, I don't know, was it 10, 15 years ago these days? And we wrote a bunch of stuff about address sizing, and that was before IPv6 was deployed. And now we have operational experience. And I think, yes, there are operational reasons to assign a 60, to assign a 64, but they are not good things to follow in the future, right? When those operational reasons disappear, like the fact that you can only do a 60 because of your 6RD pools are given size, we should move towards 56. If you have a native network, there is no reason why you can't do 56. And if you don't know that as an ISP, you should. Now, if there are operational reasons, sure. I mean, reality takes precedence over wish lists. But we have to say something here, because otherwise people might just choose whatever everyone else is doing, and then we'll just fall into a minimum common denominator trap, and we shouldn't do that.
Thank you.
Eric Klein. I guess I wanted to ask, is it more appropriate to have RIR documents in this context? Does this need to be an IETF level document? Do we need to have a RIRs?
In my opinion, and that's why we worked on this, we need to have documents in different directions.
Do the RIRs need an IETF document to refer to?
Yes, it's good sometimes.
And I'd like to let Mark into the queue.
Yeah, 2 points. 6RD, there's nothing stopping any 6RD operator from deploying /48 to every one of their users. It's only when you start shoving the whole /32 from IPv4 into the address that you actually become size limited in the number of prefixes. And what we really need to do is start trying to describe how to not waste addresses, be that the instructions to enterprises on how to actually allocate addresses. So if you're an enterprise and you actually just assign a /64 on demand, you have 65,000 /64s to hand out. You don't need to have internal structure when you're an enterprise. It might be nice, but handing out the addresses doesn't require internal structure. It's that sort of thing that ends up wasting addresses. We have routers, they know how to route things. Giving guidance to the end sites on how to actually deploy IPv6 in such a manner that you do not waste addresses. Stop encoding things into addresses which shouldn't be there.
Okay, so.
Thank you.
Jeff Houston again. Look, either we're all commonly amnesiac and we just simply forget everything, or we endlessly repeat these conversations so we can get more and more expert at reciting our positions. Neither of these correspond to progress. There is nothing in 6177 that said use a /64. Nothing. It actually says the opposite, as you might recall. What it did say, which is what you seem to be contradicting here, was that one size fits all is wrong. And the whole idea of classful addressing, as we learned in V4, was actually a hideous mistake. And deployments and operators have enough nous to figure out what they need to do. And trying to do one size fits all creates such gross and extraordinary wastefulness of address space that even the 128 bits of V6 get wasted almost immediately. We can get through this space in a year if we really want to, because we're endlessly inventive. I do not see anything in this draft that justifies why we should be doing a BIS on 6177. To me, this seems like a complete waste of time. What we said then is true now. There is no one size fits all. Go pick what you need to do. By the way, a /64 to end sites is kind of difficult for those end sites. You really shouldn't go there, or if you do, understand very clearly what you're doing, because it's not the best idea. Beyond that, go figure out what your customers need and do the right thing by them. Not, as you're saying, strongly suggest going back to the exact same problem that prompted 6177 to come up. So, you know, I'll keep on saying this and you'll keep on doing that throughout the next 5 years and we'll all feel good about it, will we? Or can we get over this stuff and actually move on to areas that are productive? Because quite frankly, cycling around these conversations is just a waste of everyone's time.
Thank you. Lorenzo Colletti, I do think we need something that discourages a single /64 because we have things like HomeNet that say that you shouldn't do that. And I think it's worth writing a document that says, look, here's what we learned and here's what we think this should look like in the future. I don't, you know, maybe 6177 says exactly what we need to say. For what it's worth, I mean, Jeff, is this just because you don't like 48? If that said 56, would you sort of be happier? Because that's actually the de facto size in RIR documents.
Lorenzo, some RIRs use /56, some others keep using /48. So it's not the standard.
Okay, then the question stands, right?
I'll try and paraphrase my understanding of RIR policy, and I don't want to be authoritative about it. But the RIRs heard very strongly in their policy fora that one size didn't fit all. And what they allowed, as far as I can see, is V6 allocations based on what the operator said they were doing. And it's not a /56 or a /48 or anything else. There is a charging structure in a lot of the RIRs where for some of them, more space means you pay more money. But that's not all, and quite frankly, it's none of the IETF's business to intrude inside that area. But no one inside the RIRs, as far as I understand from policy perspective, is saying it's 56, 57, 58 or whatever. That's not the business anymore. We went very...
Some of them have recommendations.
This is not an RIR meeting.
Okay.
The second thing is 6177 says very clearly, don't go down the /64 path. And I really don't understand why we're having a debate about that, because as I said, you couldn't make it much clearer if you actually read the text. So I don't see where the problem is on that side.
So you say this is basically already stated in 6177. Okay.
People is not reading that way.
Hi, Suresh Krishnan. So just pushing back on the last one, and so going back to 3314 from 2002, like we had this discussion and we really recommended 3GPP to go with /64. And there was like a big battle to get it pushed down there. People say, oh, that's like really wasteful and everything. I just don't want this to be reopened again, at least for the cellular. I know like Lorenzo is going to come back here probably, but everything that needs to be said has been said in 7934. Okay, it says like what can you do with the /64, what you cannot do. So I think that work, at least for the cellular side, is done. Like I don't want like anything specific saying put in a bigger prefix for a cellular network, because this is like really entrenched and we're really happy that this happened, that everybody got a /64 so you can do like creative things like you know, like 464xlat, or you can do things like, you know, 64 share and things like that that came out because we did a /64. So I just don't want this to be revisited anytime soon.
from the Jabber room. Brian Carpenter says, RAC 6177 says, hence, this document still recommends giving home site significantly more than a single /64, but does not recommend that every home site be given a /48 either.
Hi, Bob Hinden. 2 points from the discussion. So certainly, if we are not prudent, we will use up this address space very quickly. We know how to do that. So we do need to be, careful what the allocation policies are. And the other thing I'd like to add is that the intent behind this was not to make the ISPs better. It was to give the end sites enough address space so they could do whatever they needed to do so there wouldn't be address scarcity like we have with V4. And that's, thinking, or at least my thinking was that the ISPs have resources and can manage address space, and they can deal with complexity at that level, but the end sites can't. And if we make it hard for the end sites to get enough addresses or having to renumber frequently, then we'll end up with that again.
Exactly. Yeah.
Lorenzo Colletti, I think, what if we said simply assigning a single /64 per site is not recommended? I mean, I think pretty much everyone agrees with that, right? And that's clearly not being done everywhere, and the reasons are varied. But I think I think even ISPs would agree with that aspirationally. They would like to assign that. And I think it's important to state that in a very simple way. As for cellular networks, Suresh, that's actually a great example of how what we said made a difference. And it's a shining example. I remember a major, one of the earliest adopters of IPv6, and the person at that operator who was pushing IPv6 was, I'm not going to name any names here, was convinced that 64 to the device was super wasteful and was really stupid. And that operator discovered after deployment that actually this thing that they had assigned to 64 because the stupid IETF had forced them to do that was like, oh, cool, now I can do 464 XLAT. And so I think there is value here. And to be honest, I do see the point that we should say, if an LTE network is an alternative to home networking, then it should assign a 56 or whatever, right? I think that's valuable. Yeah. And we shouldn't say like, oh, don't assign a 64, right? But to the earlier point that mobile networks don't support DHCP6, well, it's written in the standards, right? It's not like it's not there. In theory, maybe the gear doesn't support it, but it's there since release 10. So, I think that's a good statement to make. If you want to provide an alternative to home routing, to home, if you're doing 5G because of your 1 millisecond or air interface time, woohoo, right? Then you should assign a 56 if it's an alternative to home networking. I think that's pretty reasonable.
Thank you.
May I cut in as an individual contributor? I like one of the things that Lorenzo said a lot, that we should have a recommendation that says a 6/64 or shorter is a really bad idea. There's also, and yes, it may already be in the existing draft. Then there's a need to specify an upper limit and an area where we give operators free rein. Anything between the upper and lower limit is just fine. Now the question is, what's that upper limit? The best thing we have to judge the upper limit, your analysis, which was clearly humorous, but not serious. And I've also heard that if we use /48s, we can run out in 10 years. That may be true, but supporting facts would be good. So maybe it would be a good idea for the two of you to sit in a room together and do a serious analysis of what number is too big.
Yeah, thank you. So Brian, I don't know if you're ahead of me or not, but I'll yield to you if you're before me.
Oh, I'm sorry. Yes, Brian. Brian, go ahead. Brian, are you there? Guess not. Okay, go ahead.
So,
Brian, come back.
so just like going back to what Lorenzo said, so there is some limitations in cellular networks. Okay, so we've done quite a bit of study on this. On a fixed network, if somebody gets a /64 and they decide they need more address space, they ask for more address space, and they can get a 48 or a 50, like 56 or 60, whatever they want, right? But the way the cellular networks are architected, they get only one prefix. It can be of whatever length. So if IETF decides like, hey, everybody should get a /32, like fine, right? But once the session is established, like putting in a second prefix is very, very difficult. So a bunch of us worked on this thing together. I think like Ola worked on it with me, and Yoni, and like few people, we worked on it. So we figured out like, how to delegate a prefix with a hole in it. So that's 6603. That came out from like, how do you take a prefix, take a hole out of it. So allocate the 64 and then allocate the other prefix on top of it. So, which is all separate from saying like, what length do we want? And but what I'm saying is like the /64 discussion back in like 2002 was like very painful. Okay, already people thought it was very wasteful back at the time. So whatever number we come up with right now, it's going to be equally painful to have that discussion. So I'm really happy that we have the 64 there, and we can try to push like further if needed. But I think 64 works well for mobile networks, like for mobiles. And as like Lorenzo said, if it becomes like more like a site that's behind a mobile network, then maybe we can come up with a slightly more targeted recommendation for other things in there. But I don't want this to be like a generic IETF, like tells 3GPP that every mobile gets a slash shorter than 64. Okay, so thanks.
Jeff Houston, I'd just like to remind the IETF and this working group where we are, because 6177 is a BCP. Now, underlying this is, where does address allocation policy happen in the internet? And a long time ago, after a lot of fights, and some of you might remember Piara, we kind of said to the RIRs, we'll give you architectural guidance, but you RIRs are the address policy fighting room. Go there and hash it out. The IETF can recommend, but it can't enforce. So 6177 says very clearly, the IETF recommends that any policy on V6 address assignment policy to end sites takes into consideration the following points, which is an appropriate language for this working group. You can't say, oh, you RIRs have to do this or that. It's beyond your scope. Your arms aren't long enough. You can't reach that far. Point one, it should be easy for an end site to obtain address space to number multiple subnets, i.e. a block larger than a single /64, and to support reasonable growth projections over long-term periods, either a decade or more. If that doesn't say, don't use 64s, I don't know what does. Secondly, typically, that's why I'm helping by reading it out. The default assignment size should take into consideration the likelihood end sites will have need for multiple subnets. So my point is, all of this is stated already. So I really don't understand exactly why we're circling around this again and again. And the real issue is the architectural guidance might come from here, but the feet on the ground is actually inside a different room.
Brian Carpenter, again, even if I don't look like him, he really says that RSC 6177 doesn't say that says first, /64 is too small, /48 may be too much, so apart from making people read 6177 again, what's new?
Lorenzo Cleary, I think we need to bear in mind that when 6177 was written, V6 deployment at the internet stood at 0.2%. Okay, now it's 2 orders of magnitude above that, and I think we can. It's kind of like amazing to me that 6177 was a BCP because there was basically no deployment, right? So it wasn't a current practice; it was a future practice. The C in BCP should have been like BFP or something. So, and to your point, Jeff, I think that text is so weaselly that people can read whatever they want into it. And I think while I would agree with you that it says don't do /64, I think there's benefit to saying don't do /64, because if that's what everyone agrees it says, then let's write it in plain English, right? If we already agree on it, don't do 64 unless you have some strong operational reason, then, what's the problem with that? Let's just write it in English, though. Let's not write it in sort of weasel words.
Stronger wording is needed.
No. Not a stronger wording, just a clearer wording.
Clearer
If
wording.
you
Okay,
word it
yeah.
strongly like
Agree,
that, you'll
agree,
get a
yeah.
lot of pushback.
Yeah.
2119? Well, I think it should be a should, right? Yeah, if you have a legitimate operational reason. Right. Yeah. So if we said should not use a 64, right? Like how many people would disagree with that? I don't think this room would. I don't think the RIRs would either, because the RIRs already say don't do this. So let's just write it in plain English and say, look, if we want to, I think from my perspective, having a clear document is a win. And I think if we want to say, look, here's after like whatever, between 0.3% and 25% of V6 deployment, here's what we learned and here's what we want to recommend, let's do that.
Thanks.
Jan Linkova, I've been listening to this, and it looks like we're just basically discussing that the few section in the original RFC is not clear enough. Should it just be a very short document saying, let's update this text with that text and that section, and we are done, making it more clear? And to Ron's point about providing upper limit, I do not think it's a problem we have now, right? Because I think practically most of the real problem is that ISP is assigned just /64 or even /128. I do not think we have problem with two blocks assigned being too large. So we probably do not, I am not sure we need to concentrate on discussion, should it be /48 or something else. We need to make sure we are not assigning too little, because it hurts. If you assign too much, well, you burn out your address space, you have to go to RIR back and ask for more address space and pay more potentially. Well, it's your problem. So my opinion, it's not a real problem.
At this point, we have to draw this conversation to a close and bring it to a spirited discussion on the mailing list.
Yes, please. I will suggest the people that have not read the document, make a diff between the original 6177 and this one, because the differences are not that much. So I agree with Jen that it may be a shorter document. Yes, this document is shorter than the original one. So we actually removed parts of the original document.
So, okay, let's take this to the list. Now, so we have one document left today, and my goodness, Jordy, you've been busy.
I have 6 more.
Yeah, so.
Okay, so this document, I think actually you suggested doing a comparison of the transition mechanism. So Gabor, who is the main author of the document, said, yes, I take it, and asked it for volunteers. So a few of us started contributing. I know we have short time, so I did a very small presentation, because the main goal of this presentation is to get inputs from the working group. Okay, so we need a lot of work here, and we don't expect this document to be an easy one or something that we are going to do in a short time. So basically, what we are trying to do with this document is there are 5 basic transition mechanisms that we call IPv4 as a service, which are 464X-LAT, DS-LAT, Lightwave 4/6, MAP-E, and MAP-T. There are a few others like Lisp, GRE on IPv6, and so on, that we decided not to consider because there is not that much deployment as the previous ones. So we prefer to concentrate on what we believe are the 5 main ones. If somebody disagrees, please state, hey, there are that many number of deployments with other documents, with other mechanisms, and maybe we will consider that. So the thing is, if we try to make a comparison between all of them to make easier for an ISP to decide. And we already know from the beginning that this is not really an easy task, and at the end it will depend a lot on every specific network case. So we have different sections of the document. Again, the document is still a work in progress and will require a lot of additional work, but we have one high-level architecture where we discuss each of the transition mechanisms, how they are traversing the ISP network, and how they are sharing the IPv4 addresses for doing this mechanism. Okay, so Summary of the document, we have a detailed analysis of the architectural differences between the 5 different IPv4 as a service mechanisms, basic comparison of all of them, trade-offs among the efficiency of port numbers and stateless operation, support for servers operations, support and implementations, including operating systems, cellular and broadband, and implementation code sites. We have also typical deployment and traffic volume. There are some figures that Cameron from T-Mobile provided to the mailing list. So we compared those figures with other similar networks, and it looks like most of them are coincidentally in that sharing. So we are basically describing the deployment possibilities, including the cellular with 464X LAT, the load sharing, performance comparison. This is something that we want to do. So this is not still done, but the idea is Gabor has some students that will be able to do this performance comparison. We still need to define exactly how we're going to do that because it's not an easy task, and that will be part of the document. And of course, we have a security considerations, and that's it. The thing here is ask to the working group to contribute. Ask to the working group, what other aspects do you believe are interesting to be considered by the document? What do you think will be useful? Barbara?
Yeah, so something I think would be useful is a number of these technologies actually have various options as to how they can be set up. You know, maybe you have blocks of IPv4 addresses associated with it. Maybe you're using NAT. Or, you know, there's all these various things. And so it would be useful to understand what are the most common configurations that are in use.
Ian Farrer. Yeah, first of all, thanks for grasping the nettle and trying to get a handle on this stuff because it's a fairly expansive task and it probably should have been done some time ago. I've had a look through it and I've got a raft of comments on the current version of there, which I'll post the list later on. But the main things I had was there's been a spreadsheet that's been doing the rounds over the last few months. I think Lee Howard and well, based on your work, that does some kind of comparison between these things based on kind of yes, no's, and you know, are very easy to look up. And is the plan to kind of incorporate this stuff and you know find some ASCII way of rendering that thing?
Sorry, is the plan?
Is the plan to incorporate that comparison table? So here's an easy and yeah, okay, good. To the performance testing, I mean, we've talked about this one already, but I've been kind of racking my brains about this as to whether can anything meaningful come out of this that isn't just going to say this implementation is faster than that implementation. You've got physical versus virtuals. You've got God knows how many different variables on here.
To be honest, we still don't know. We are still thinking about how to do that and how to put that in a document because we know that there are pros and cons to every possible option. So yeah, I am not even myself sure about how we will be doing that.
My gut feel here is that unless you're comparing different implementations of a single technology, you know, you can't come out with anything meaningful here. Right. And there's you know, the risk of, well, a very time-consuming, inconclusive waste of time there.
Well, the advantage is that we have students that are happy to do that. So
yeah, but I mean, do they have access to all of the different hardware and software implementations of these things?
That's another part of the problem. Yeah. Right.
Unless they're very well resourced, I doubt it.
Yeah. Thank you.
Okay, so now at this point, we have only a couple of minutes left until the top of the hour. Are there any further comments that people want to make to Jordi on this draft? Seeing none. Okay. The time is now 10:54. I think by the time we do anything, it's going to be 11, and 11 we're done. So I'm going to adjourn at this point. We're going to come to a close.
Thank you.
No.
Jordi, a little sidebar. That's where Jeff did. Also,
assume my slides remain based, is that?
Yeah, sure, sure.
Hi, Paul.